Hello. So yesterday we worked on writing equations, and then today we're going to work on solving them. So if we are solving one-step equations, that means there's only one inverse operation that we need to do. So if it was like x plus 3 equals 5, we would just need to do the inverse operation of addition, which is subtraction, and subtract that over, and that we would have our solution. So with two-step equations, we have two steps that we need to do. And that means we might need to add and divide or add and multiply, and it just depends, but you're going to need two different operations. So the first thing I like to have kids do is draw a line down from the top to separate from the top equal sign to separate the two sides of your equation. Now, whatever is done to one side of the equation must be done to the other side to keep it equal or balanced. So it's an equation, meaning that whatever's on one side is equal to what is on the other side. So think of it like your brothers and sisters. If you get one thing, they want to get one thing to try to keep it equal. So same thing goes with our equation. Whatever I do to one side of it, I have to do the same thing to the other side to keep it balanced. You're going to do the inverse operation and the reverse order of operations. And then isolate the variable. And then check your answer by plugging it back into the equation. And remember to pause this, listen back to it, whatever you need to do to help you understand what's going on and to make sure you're not missing anything. So we're going to do a couple of these because I think all those words will make more sense as you see them in use. So my first equation is 5x, or 5 times x, plus 26 equals 46. In other words, 5 times some number, then I add 26 to it, I'm going to end up with 46. So I find that equal sign at the top, and I'm going to draw a line down the middle. What this tells me is whatever I do to this side of the equation, I end up doing to this side of the equation. So we're going to go reverse order of operations. So normally I would take care of multiplication and division before I added and subtracted. That would be the correct order of operations. Since we are solving equations, we're going to actually go backwards. So we're going to start at the bottom and take care of addition and subtraction first. So in this case, I'm adding. I need the inverse or opposite of that. So I'm going to subtract 26 from both sides. Now over here, a positive 26 and a negative 26 cancel each other out. They equal 0. So I'm just going to cross them out. I can still see over here that I have a 5x left. And I am going to bring that right down because I still have that left. So now 5 times some number is going to equal 46 minus 26, and I get 20. Now I'm down to a one-step equation, which I'm sure you recognize, and I have 5 times some number equals 20. So the opposite of multiplication is division, and you want to start showing that division as a fraction. So 5 divided by 5 is going to give me 1x, which is exactly what I want. Now we don't typically write the 1 there, we just have an x, and so we know that that equals 1. Now if I divided by 5 on this side, I also have to divide by 5 on this side. So 20 divided by 5 equals 4. So I think that my x is equal to 4, and I'm going to check that out. So 5 times some number plus 26 equals 46 is my original equation. I'm going to take whatever I found for x, and I'm going to plug it in for my x. So now I'm going to have 5 times 4 plus 26 equals 46. Well, 5 times 4 is 20, plus 26 equals 46, and 46 equals 46, so that means that I must have the right answer. You'll notice that when you check your answer, you do go back to following the order of operations in the normal order as opposed to the reverse order that we do for solving the equation. Right next door here we have some number divided by 3, so n over 3 minus 14 equals 1. So the first thing we're going to do again is the inverse order or opposite order of operations. So I'm going to take care of addition and subtraction first. So if I am subtracting 14, after I draw my line down, I need to add 14. Whatever I do this side, I need to do to this side. Now once again, my negative 14 and or subtracting 14 and my adding 14, those cancel each other out. Those are additive inverses. All I have left over here is that number divided by 3, and that's going to equal 1 plus 14, which is 15. Now I'm dividing by 3, and the opposite of dividing by 3 is multiplying by 3. And if I multiply by 3, I can think of that as 3 over 1 on this side, and just times 3 over there. If you remember, when you multiply fractions, you can cross-reduce. Those cancel out. So I would end up with n over top of 1, and anything divided by 1 is just itself. Now you can skip this step right here once you start to realize that those cancel out and it's gone, so I just have the n. Now 15 times 3 is 45. So I think that my answer is 45. When I go over here to check, I start out with my original equation, and then I'm going to plug in what I think the answer is. 45 divided by 3 this time is 15 minus 14 equals 1, and 1 equals 1. So once again, my answer checks out. So now I have negative 11 equals negative 5b minus 6. Lots of negatives. Don't be scared. You got this. Also, another thing that you notice on this one is my variable is on this side instead of on this side. If that bothers you, take the equal sign, put it over here, and move the negative 11 over. That's absolutely okay. So what that would look like would be, instead of drawing that line down the middle there, I'm just going to show you how to do that on this problem. You don't have to do this, but you can. Cross out your equal sign there, add it over here, cross out your negative 11, and make sure you bring a negative 11 over there. So now this keeps your variable on the left, which is what you've gotten used to, and so you might be more comfortable with that. When I'm finished, I'll go back and erase, and I'll show it with it on that correct side, so you can see you get the same answer. So once again, I'm subtracting 6. So in order to undo that, I'm going to add 6 to both sides. My negative 6, my positive 6 cancel out. I've got negative 5b equals negative 11 plus 6. Remember those integer operation rules. So negative 11 plus 6 is going to be negative 5. I'm then going to divide both sides by negative 5. Negative 5 divided by negative 5 is a positive 1, which is what we're looking for. And negative 5 divided by negative 5 is also a positive 1 over there. So we think that b is equal to 1. I can go back to that original equation to plug it in. I can also use the one that I changed. I'm going to show you that I still should get the same thing here if I plug my 1 in there. So negative 11 equals negative 5 times 1 minus 6. Negative 5 times 1 is just negative 5, and negative 5 minus 6 is indeed negative 11. So since those are equal to each other again, my answer checks out. Now what I'm going to do right now is I'm going to pause for just a moment. I'm going to erase what I wrote and then show you how you can do that. Alright, so here's what this would look like if I left the negative 11 over there. I would do the same thing. I've got my variable here and I want to get it all by itself. I need to isolate it. So if I'm subtracting 6, I would add 6. My negative 6, my positive 6 would cancel out. I still have negative 5b. That's what I have left over there. Negative 11 plus 6, I still get negative 5. I still want to divide by negative 5. And I still get that b is equal to 1. Moving over here, we've got another one of those division problems. I'm going to draw my line down. I'm adding 8, so I'm going to subtract 8 to get rid of it, because once again I'm trying to get that variable all by itself. So positive 8 and a negative 8 cancel each other out. 19 minus 8 is 11. Now I still have over here that y over top of negative 7. Now it's really important that when I go to multiply this, I'm not going to multiply by a positive 7 because I'm not dividing by a positive 7. I'm dividing by a negative 7. So once again, I can think of that as negative 7 over 1. I'm going to multiply this side by negative 7 as well. These negative 7s are going to cancel each other out completely because I would end up with negative 7y over negative 7. And anything divided by itself equals 1. So I end up with 1y. So just kind of the longer way of thinking about that. Over here I have 11 times negative 7, which is negative 77. When I go back and plug that in, negative 77 divided by negative 7 equals a positive 11. And I get 19 equals 19. And once again, my answer checks out. Down here, a couple more. This time you'll notice that my variable is here. It's being multiplied by a fraction. And out front, I have this negative 5. So this negative 5, I need to do the inverse of this. I need its additive inverse to cancel it out on this side to get my variable all by itself. So I'm going to add 5 there, which also means I'm going to add 5 over here. And I do this because, once again, I need to get this variable all by itself. So negative 5 plus 5, those cancel out. I have 3/5 times a equals 15. Now, you're like, man, I've got a fraction. How am I going to do that? Well, you're going to multiply, but you're going to multiply by its reciprocal. And if you remember, the reciprocal is the fraction just flipped. Whatever I do to this side, I'm going to do to this side. So once again, if you remember, this is going to be 15 over 15, which equals 1, or I can think of them as cross-canceling. So I get 1a. Over here, I get 15 times 5 divided by 3. I can also cross-reduce there if I want to, and I'll get 25 over 1, which is equal to 25. If I go back and I plug that in, those once again will cross cancel. So I've got negative 5 plus 15 equals 10, and 10 equals 10. I know I'm moving through these quickly, so if you need to pause them, rewatch them, work through it, whatever you need to do, feel free to do that. This last problem here, I'm going to draw the line down. Now, normally we take care of addition and subtraction first, but you see how it's trapped in the numerator. So I need to get it untrapped from a numerator. In order to do that, I'm going to take care of this negative 3 first. Now I am dividing by this negative 3. So just like with all things in life, there usually seems to be at least one exception, and this is one of those. So instead of starting out with taking care of the addition there, I've got to take care of that division with that negative 3. So I'm going to multiply by negative 3. But remember, whatever I do to one side, I have to do to the other side. So these 3's will cancel out. I will get 4x plus 5 over top of 1. Well, anything divided by 1 is itself. So now I've untrapped that addition and the rest of my equation from that numerator. Over here I've got negative 7 times negative 3, so that's equal to 21. And now this looks like something I've been doing. In the top, I'm going to subtract 5 from both sides, divide by 4, and I get x equals 4. I'm going to pause, and I want you to plug it in and see if you can get it to equal and find out if it's the right answer. All right, so go ahead, take a look at how I plugged that in and checked it, and see if you were able to do the same thing. Then our last problem down here, it says the perimeter of a rectangle. So I'm going to draw my rectangle. It says the perimeter is 31.8 centimeters. If the length of the rectangle is 8.9, what is the width? Well, I do 2 times the width plus 2 times the length.